An example would be the Manchester 737 accident in 1985, when 55 passengers perished. On takeoff, there was a loud bang from the port engine, and the pilot brought the plane to a stop. There would have been no loss of life had it not been for the fact that an explosive rupture of the engine had taken place and flying metal had shattered a wing fuel tank. Fuel was released in large quantities and immediately ignited. The ensuing fire burnt through the fuselage into the cabin, and the majority of the deaths were caused by inhalation of smoke and toxic gases. As it can take up to 3 minutes for the airport fire services to attend a crashed plane, the problem to be addressed is how do you protect those passengers for that so critical few-minute period? A possible solution is an on-board cabin water spray system. Preliminary experiments aimed at simulating the post-crash fire scenario have been carried out at the Grangemouth test facility. The open doors of the container represent a break in the fuselage, outside of which we light a 35-litre pool of aviation fuel. A bank of 3 airline seats is placed at the entrance to the container. In the first experiment, no sprays are used. The fire is merely allowed to develop and burn through to extinction. All the time, measurements are taken inside the container. Soon, the conditions within the container become unbearable, and the intense radiation causes the seat nearest the fire to catch alight. The cabin fills with thick black smoke. At the end of the experiment, the damage caused by the fire is obvious. The experiment is repeated, but now with 4 elevated nozzles providing a water curtain between the fire tray and the seats. Water neither enters the fire tray nor impinges upon the seats. The fire is lit, and after 20 seconds the spray is activated. An interesting observation is the formation of a Venturi effect, which tended to suppress the fire and move it to the outermost edge of the fire tray. Upon initiating the sprays, radiation and temperature in the container are knocked down to ambient levels almost instantly. There is now very little smoke, and the fire does not enter the container. The fire has now burnt itself out, but the aircraft seats are completely undamaged. Further evidence of the effectiveness of the barrier produced by the water mist curtain.